26. Which of the following is a pure substance? A pure substance could be element and could be a compound, but it cannot be a mixture. So pure substance is not a mixture. It is either an element or a compound. So let's see the choices given here. Air is a mixture of gases, so can't be the answer. Salt water is a mixture of salt and water. That can't be the answer. Oil and water also. That is what happened. So oil and water, that's always also a mixture. So it can't be A, B, and C. The answer is just oxygen gas. And the formula of oxygen O2. You don't have to know the formula, but as I said, pure substance is either an element, which is an element, or a compound. So the answer is C. Now this diagram here, I'm just giving examples to differentiate between elements, compounds, mixture. The 1 unit is an atom. The whole is an element. That is a pure substance. Now, this one, since I see two different atoms combined together, the 1 unit is the molecule, 1 unit, but the whole thing is a compound. And that is also a pure substance. Why? Because all the compounds or all the molecules here are the same. When we look at this one, this is a molecule. So these are compound, and this one over here is a different molecule. So the other units together makes it a different compound. So diagram 3 is a mixture of two different compounds. So I call it a mixture. Another one, that is an element, that is an atom, the 1 unit. And because all atoms in this diagram are the same, that is an element, pure substance. The 1 unit is a molecule, but the whole diagram is a compound and not a mixture because all the molecules here are the same. Now, if we look at this diagram, I see two types of atoms. The 1 unit is an atom, and this one is a different atom. Now, I can say that this is a mixture of elements. All of this, element 1, all of this, element 2. So that's a mixture of elements. Now, if you see the way they are mixed, it's clearly the element 1 atoms are together, separated from the atoms of element 2. So that makes it a heterogeneous mixture because the mix is non-uniform. Whereas if you look at the one over here, you see the different elements in it. So again, that's a mixture of elements, the green element and the pink element. So that's a mixture of elements, of two different elements, but they are mixed in a uniform way. So it has one appearance. So we call this type of mixture homogeneous mixture. Again, here's an element. This is an atom. Together makes it an element. Also, element could be a combination of two atoms of the same type. So again, This is another type of element made up of a molecule of two same atoms. Compound. The whole thing is a compound, but the smallest unit of a compound is a molecule. So again, the one, I can call it also a molecule. The one is a molecule. The whole thing in this example is an element, whereas here the whole thing is a compound. Why? Because the atoms are different, blue and red. Again here, the one unit is a one molecule. The whole thing is a compound. Looking at this one, this is a mixture. Oh, what's happening? It got erased. So that's an atom. The whole thing is an element. That's an element. That's a molecule. The whole thing is an element because we have two same atoms combined. Again, that's a molecule, but the whole thing is a compound. That's a molecule, but the whole thing is a compound. In this one, that is a mixture because when I look at it, I have molecule A and I have a different molecule B. So I'm going to call this molecule A and this molecule B. Now, A, A, that makes it compound A in this diagram. And B, B, and B, that makes it compound B in this diagram. Therefore, this is a mixture of different compounds. So one, that's a mixture of two different compounds. Looking at the second diagram, I have atom A. Atom A and atom A all together in this diagram make them element A. Now, the blue one is element B, sorry, or wait, molecule B. Now, the two molecules of B together, they makes it the element of B. I cannot call it compound yet. Now, this one is another type of molecule C, but all the molecules of C together constitute the compound of C. Now, this diagram over here is a mixture of element A with compound or element, I can call it also element B, and compound C. Last one is also a mixture of element A and a different element B. So that's the explanation of this. A compound is best described as a compound made of only one type, that's for element. It's made of two or more different atoms chemically bonded, that's correct. A physical combination, that's a mixture. A homogeneous mixture, that's a type of mixture, because mixture can be heterogeneous and homogeneous. Which of the following is a heterogeneous mixture? It means a mixture where I have a non-uniform mixing, a mixture that has more than one appearance. So, salt water, they didn't say sea water because sea water is mixed sand and water and sea شو اسمه weeds, seeds, the green leaves in the water. So salt water, I only see the water. I have to taste it to know that there is a salt. So this is homogeneous. They want the heterogeneous. Air as well is homogeneous. Why? Because I cannot differentiate between the gases in the mixture of air. Lemonade, and it's written without pulp because if it is with pulp, then it becomes a heterogeneous mixture. The only correct answer in this choice is B because when I mix oil and water, I can still see clearly the oil separated from the water, which makes it a non-uniform heterogeneous mixture. Oh, there is something going on with my iPad. I'm very sorry. It's disappearing, but it's in the recording. So, which laboratory apparatus is used in filtration? So, if I have a filtration, I need a conical flask, I need a funnel in that conical flask. Inside the funnel, I'll put a filter paper. What is left out in the filter paper is called residue, and the clear substance I receive in the conical flask is called filtrate. So, what do I need for filtration? I need a funnel and I need a filter paper. I don't need an evaporating basin. Chromatography paper is for the chromatography separation technique, and distillation apparatus for the simple or the fractional distillation apparatus. So the answer is A. Again, here I am showing you a filtration separation technique. So again, this is the mixture of that needs to be separated. For the filtration, filtration is best used to separate heterogeneous mixtures. I cannot separate a homogeneous mixture. And the heterogeneous mixture that you want to separate must be made up of a solid and the liquid part so that the solid is trapped at the bottom of the filter paper and it is called residue, solid. So that's the solid part. And what passes through the filter paper is the liquid part, which called the filtrate. Now, a glass rod is not mandatory in a filtration, but it could help. Filter funnel, a filter paper and a funnel and a receiving flask are mandatory in a filtration technique. Now here is more label ring for support, of course, to hold the funnel. This is the filter paper. This is the flask or the conical flask. And this is the filtrate. What is trapped over here is called the residue. Moving on. Separating colors. Color dyes, color pigments for ink is always done by the chromatography technique. Distillation is used to separate two liquids, two or more, yani for two or more liquids, and it is based on their boiling point differences. Filtration is to separate a liquid from a solid, a heterogeneous mixture. Same thing for decantation. The law of conservation of mass. Conservation means save, to keep the same. So during a reaction, during a physical change or a chemical change, the mass before of reactants, I'm very sorry for what's going on. So the law of conservation of mass, again, so to save, to keep the same, to keep mass the same. So the mass of reactant must be equal to the mass of the product. If you look at the examples over here, this is before and that's after. How do I know? There's this arrow separating them. So the sulfur and the iron before, together, they had a total mass of 88 grams. And after they reacted, they gave me the final product, which again the mass would be 88 grams. So the mass did not change. I can give you a question in the quiz, just like the second quiz you had. We had an example of a reactant and asking you, for example, I can hide this and tell you how much is the mass of oxygen. Now, 93 plus whatever mass of oxygen should be 100. Therefore, if you subtract, you get the mass of oxygen. As you can see, mass did not change, conservation of mass. Now, the statement salt dissolves faster in hot water than cold water is an example of a hypothesis, a theory. This is, a hypothesis. The sentence, the statement must start with if or any word, same meaning to if, because it's a guess. I am guessing. I didn't check it yet. Okay? Now, this is definitely not a law, but maybe this is coming after an experiment, and we clearly observe, we see that the salt in the hot water dissolves faster than in the cold water. So this makes it an observation. If it is a theory, it will be clearly stated as a theory. For example, if it's also a law, it will be stated clearly as a law. I think I missed answering this one. The law of conservation of mass states mass cannot be created or destroyed in a chemical reaction. That's a law. Okay? An oxygen molecule O2, because O with O. So the atoms are the same atoms. So I can call it a molecule or I can call it an element. I cannot call it a compound. That's not a mixture. So that's an element. Physical properties such as colors, density, boiling point. These are physical properties because we're not talking about a potential change in the identity to be a chemical property. Now, physical properties can be classified into intensive properties and extensive properties. Intensive property, intensive, is independent of the amount of matter, of the quantity. Okay? Extensive depends on the amount of matter. So, بالنسبة للدensity, for the color, even the boiling point, quantity here does not matter. So, that's an intensive, these are intensive properties. Which of the following is a chemical change? Chemical change is a change that changes the identity of the substance. So the substance does not stay the same. Look for the words like rusting, flammable, burned, effervescence, these things. But crushing is not a chemical change. Melting, boiling, evaporating, freezing, these are not chemical changes. Dissolving is not a chemical change. But burning is a chemical change because the paper will turn into ash. It's not a paper anymore. Which state of matter? Physical states. These are the physical states. So they want which state of matter the particles are closely packed in a fixed, or I might use the word vibrating positions. It's the solid. The liquid particles slide past each other. The gas, the particles are freely moving. So here's the solid. They're very close. Liquid, they are close, but not that close. And the gas, they're far away from each other. In the solid, we see a regular arrangement. In the liquid, they're randomly, or this might confuse you, they slide past each other. They move around each other. In the gas, there is no order. Here they vibrate, here they slide, here they move randomly in all directions. Now, this is a question that I gave in the homework. What I want to add on this is that density, solids will have the highest density. It's a bit larger than the density of liquid, but when I compare it to the density of gas, gas has a lot way more less density than solid and liquid. Concerning compressibility, if I compress or no the state, solids are incompressible. Liquids are incompressible. Gas, they can be compressed. Why? Because there is a space between them, and I can reduce this space by compressing them. So in which state of matter they are highly compressible? It's the gas. Which of the following is extensive? They're not telling me intensive. Extensive. It means depend on the matter, quantity of matter. So that could be mass, volume, weight, energy, thermal energy in something, not the density, not the color, not the boiling point. And in the revision notes, I gave you a figure and I listed in it few examples of extensive properties and few examples of intensive property. Oil and water. Yes, they do form a heterogeneous mixture because I see the oil and below I see the water. So they chemically react? No, it's a mixture. Mixtures, they don't chemically bond. They cannot mix due to different densities. Yeah, they can't mix. They cannot mix. That's why they are heterogeneous. They don't form a compound and they definitely do not evaporate together because they are different substances. They will have different boiling points. The separation technique used to obtain pure water from seawater. Now, let's look at the given options. Filtration can't be used here because the seawater, the salt is dissolved in water. To use filtration, I need a heterogeneous mixture of solid with a liquid, so can be used. And they are here, they are colorless. We are not separating colors here, so I cannot use chromatography. Decantation is very similar to the filtration. I cannot use it here. I need solid particles. So the only thing I can do here, use distillation. Now, if their boiling point are close from each other, I will use the fractional distillation. If their boiling point are far from each other, I will use the simple distillation. So now, let me just remind you with the simple distillation technique versus the fractional distillation technique. Both of them, they need a condenser. Both of them, the mixture will end in a receiving flask. Both of them, the mixture at the beginning is mixed in the distilling flask. Both of them, we need a heat source to heat the mixture so that the temperature starts increasing and we reach the boiling point. Both of them, there is a water in, water out, and water in to cool down the vapor passing through the condenser. to condense it back again to liquid. The only difference between them is that the fractional distillation contains a fractionating column. The simple distillation doesn't have this fractionating column. And the reason we have a fractionating column to separate mixtures composed of close boiling point substances. The substances in this mixture over here, their boiling point is not so far from each other. So I need a fractionating column. Whereas here, I can use it to separate liquids having 4 boiling points. So their boiling point are far from each other. I don't need a fractionating column. So they will be separated. The one that's having the lower boiling point will be first obtained in the receiving flask. The one that is having a higher boiling point will remain in the distilling flask. Moving on. These are short answer questions. State the difference between an element and a compound. They want the difference. So I'm not gonna say the similarities. The similarities that is that they both are pure substance. Now the difference. An element is made up of the same type of atoms, whereas a compound, chemically bonded, okay? And now, whereas a compound is made up of 2 or more atoms. Now, I'm gonna add to this. Element can't be broken down by any chemical means, can't be separated by chemical means, يعني in a chemical reaction. But here can be broken down, can be separated, but the separation must be done chemically. What do I mean chemically? And not by these separation techniques that I am showing you over here. Okay, so this one can be separated by chemical ways, chemical means. Write down one example of a physical change. Cutting a paper, melting whatever you want, melting ice, freezing water, evaporating juice. So cutting, melting, freezing. Go for the simple examples. Condensing, evaporating, crushing, evaporating, crushing, grinding, cutting, breaking. All of these are physical changes. Chemical change is different. Chemical change, burning wood, paper, burning anything you can put after burning. You can burn anything. Or reacting with what blah blah. So you can say reacting with oxygen, rusting, corroding means corrosion. Anything that can change the chemical structure. Chemical change, yes, rusting, corroding, burning, reacting. Okay, now a student has a mixture of sand and water. That's a heterogeneous mixture. Describe the steps to separate both substances. So we can say, how do we separate them? This is solid from liquid. Filtration is the best way. The student needs to do a filtration. And here
Miss,
in the
this is
filtration,
sand and salt.
Oh, yes, sorry, sand and salt. But I will still need to do a filtration. You're right, sorry. So, but I still need to do a filtration. So, because I have sand and salt, we need to do this in 2 steps. Step 1, add water, because I know that salt dissolves in water, sand doesn't. Add water to the mixture to completely dissolve the water. I think it's in 3 steps. I'll tell you why 3. 3. Now, step 2, set up a filtration apparatus by bringing a conical flask or an Erlenmeyer flask, a conical flask, a funnel, and a filter paper. So just like this. Here's the funnel, and you put the filter paper inside. Start the filtration. Start the filtration. The solid, the sand, which is the solid, will be trapped by the filter paper, and in this part it's going to be called residue, and the salty water will be obtained in the receiving flask, will be obtained in the receiving flask, and that's what we call filtrate. Now, that's why I said step 3, I still need to get the salt. So, set up an evaporation technique, and here by placing the same receiving flask, by placing the receiving flask over a tripod. You can skip this step and saying just by placing a receiving flask over a Bunsen burner, but I'm just making it more detailed. By placing a flask over a tripod under which a Bunsen burner, under which you have a Bunsen burner, a Bunsen burner. And this way you are also mentioning that you know the name of the equipments. So it's going to be like this. This is the tripod, and here's your receiving flask, and this is the flame of the Bunsen burner. So start heating the mixture until the water completely evaporates, and you are left out with the salt crystals. And salt crystals will remain in the flask. So like this, you dissolved the salt, you filtrated the sand and salt to obtain the sand, then you did an evaporation to separate the salt from the water by evaporating the water. Eventually, you were left out with the salt crystals. Define the term mixtures. List two differences between homogeneous and heterogeneous mixtures. So first of all, a mixture is when different, I can say two or more, or I can say different substances are mixed, placed together, and they are not chemically combining, they're physically placed together, are physically, not chemically, mixed or placed together. A mixture can be separated. Now, we have two types of mixtures, a homogeneous mixture and a heterogeneous mixture. So the question wants two differences between them. A homogeneous mixture is a uniform mixture. Substances are mixed together in a uniform way. And this one is a non-uniform mixture. That's the first difference. The second difference, it has one appearance. You know, when I'm looking at it, I only see one thing. But when I look at the heterogeneous mixture, has more than one appearance. Appearance. Okay. Moving on with the question. See, this is a question to apply the law of conservation of mass. The question says, a closed flask, a sealed flask, it has 20 grams of hydrogen and reacts with oxygen. Did they mention the mass of oxygen? Not yet. To form 90 grams of water. What is this mass? So 90, because the law of conservation of mass, the total mass before is always equal to the total mass after. It means that 20 plus how much is going to be 90? I can say 90 minus 20, and I'm going to get 70 grams. That is the mass of oxygen. Y density is an intensive property. Intensive property, so is a physical property that is independent of the quantity of matter. So is a physical property that does not depend on matter, on amount of matter. Amount of matter. Now, if you remember, when we did the activity in class, that paper that we filled, you were given different masses of the same substance with different volume for the same substance. And every time you were dividing mass over volume, you were getting the same answer. Okay? So, density of a substance does not change no matter how big or small, how big or small a substance is. And you can here give an example. A piece of wood, a piece of wood will float in water whether it was small or large. So the quantity here is not important. Will float in water whether it was small or large. That's a simple explanation. Now, just like your second quiz, you got this question where you have to state whether this is an observation or a hypothesis or an experiment or a theory or a law. Now, let's start reading. If the temperature of water is increased, salt will dissolve faster. You see, if I read this sentence simply like this, the temperature of water increased, or I can start say, the salt dissolved faster when temperature of water increased. This becomes an observation. But because this sentence starts with an if, it means we are trying to make a guess that we will test later. So this is a hypothesis because of the if. So I repeat, if the sentence was just written, salt dissolve faster when temperature of water increased, this becomes observation. Now let's read the first sentence. When a candle burns, water vapor and carbon dioxide are formed. Now, this one is a theory. It's a theory. When a candle burns, because we're not trying this, and we didn't see, we're just, this comes after maybe an experiment, and here's the theory is done. Theory. Now let's see other one. A student heats salt water to collect pure water and measure the remaining salt. This is a step in an experiment. This is kind of a procedure. So that's an experiment done over here to test the water and the salt. All matter is made up of tiny particles called atoms. So what's remaining here? We used experiment, we used hypothesis, we used, wait, made a mistake here because I still have observation, theory, and law. So this one, that's an observation. That's my mistake. So let's read it again. When a candle burns, you know why it's an observation? Because it started with a when. It means that I'm telling you that I did this change or this whatever, and I saw that carbon dioxide and water vapor were observed. So that were seen. So that makes it an observation. See, the observation and theory are a bit confusing, but here, when is helping me to understand that this is an observation. Now, look at this one. All matter, there is no end. So this is a firm sentence. This is like something general that was made. All matter is made up of tiny particles called atoms. Mass is neither created or destroyed in a chemical reaction. We know that this is the law of conservation of mass. So that's a law, and this is a theory coming from the atomic theory. Are there questions for this part? Here's another example. Again, observation, hypothesis, experiment, theory, law. Let's look for the guess hypothesis. If the temperature is increased, sugar will dissolve faster. Hypothesis. Let's look for like experiment or step, something that will show me that as if I am doing an experiment. Salt crystals disappeared when stirred in water. The student heated the mixture and recorded the temperature. That's an experiment, something that we are doing to test our hypothesis. So, hypothesis, experiment. Now, the salt crystals disappeared when we mixed. So we are seeing this. Observation. Now, usually when we give you the question, all the statements are related so that you can arrange them. So first we start with hypothesis. If the temperature is increased, sugar will dissolve faster. Then we will do the experiment. We did the experiment and that's what we observed. By the way, we can put observation before hypothesis and vice versa. And then we can come up with a theory or a law. Matter is made up of tiny invisible particles. That is a theory. And the law of conservation of mass, mass is conserved during a chemical reaction. Name the separating techniques. So this one is a filtration technique, and you need to know all the components. Yani this is a ring stand, this is a support, this is a funnel, this is a filter paper, that's a funnel I said, that's a receiving flask or an Erlenmeyer flask. Down in the filter paper, there is the residue, and down in here, I get the filtrate. Again, filtration is the perfect separation technique to separate a heterogeneous mixture made up of solid and liquid components. Not just think about oil and water. Oil and water can go here. I can use a separatory funnel. Separatory funnel is used to separate different liquids having different densities, cannot mix. Yani I can use a separatory funnel to separate a heterogeneous mixture made up of liquid components. So once I open the stopcock, the liquid with a lower density will start coming out. Then once the oil reach down, I can close it. And like this, I can have water here and oil up in there. This one is a paper. Don't forget to write paper. Paper chromatography, because in the lesson to chromatography, in the lesson on classic, I also showed you the figure of a column chromatography. So in the paper chromatography, I need a paper, which is the fixed static, fixed phase, and the solvent is the mobile phase. So what you do, you draw a line on the chromatography paper with a pencil, and on the line you place a dot of the ink to be separated. So it is the chromatography is for the separation of colored ink pigments. So you put dots of the colored ink, different inks, okay? And then you let the bottom of the filter of the chromatography paper touch the solvent. And then the solvent, because it's a mobile phase, by capillary action, it's going to start rising up the paper chromatography and lifting, holding with it the components of the ink. And like this, every color will be separated. So what's not moving is the paper. What's moving is the solvent by capillary action. To calculate, but calculation are not included, but I mean to calculate, we divide the distance traveled. So let's say this one. We measure the distance traveled by this ink. Let's say here's the line we draw by the pencil. And we divide it by the measure traveled by the distance traveled by the solvent. We can know, we call it RF. For example, this over here, this ink apparently is made up of 4 different colors, whereas this ink is made up of 3 different colors and this ink of 2 different colors. another thing, this ink and this ink has two common colors, whereas this ink and this ink has two common colors, same colors. And here I have decantation. And decantation is like filtration, but it's much faster and simpler. And this one is a fractional distillation. Fractional distillation. So as I mentioned, the fractional distillation is used to separate mixtures of boiling point liquid mixtures having close boiling points to each other.